Let's take another example of latent heat of fusion. An ice cube was melted. Calculate the energy absorbed. Because the melting point of water is higher than -17 degrees, we have to first calculate the heat required to warm up the ice cube and then the heat required to melt the ice cube. The heat energy absorbed is sum of the heat required to warm up the cube to melting point and heat required to melt the ice cube. Let's note the melting point with T with lower index m, total energy required Q, warming energy Q with lower index m, and the melting energy Q with lower index m. We have to search the specific heat capacity of ice and the latent heat of fusion for water. So I googled specific heat capacity for ice and took this engineering table and selected this temperature -20 degrees of Celsius or above, and I approximated that the specific heat capacity of ice is around 2 kilojoules per kilogram Kelvin, and I can recall the latent heat of fusion for water from example earlier. The latent heat of fusion for water is 333 kilojoules per kilogram. Then the next step to solve this problem was that I wrote down the initial values and changed the units proper. Then I wrote down the formula. First formula is the total energy absorbed, which is energy required to warm up the cube plus heat required to melt the cube. Then I wrote down the equation of latent heat. I also wrote down equation of specific heat capacity, and I also wrote down this equation to change of temperature, which was final temperature minus initial temperature. First, I solved the heat energy required to melt the ice cube from formula 2 in the similar manner as I solved it in example 1. Then I solved the whole equation. Q is QV plus QM, which I put in these values of QM, which is Lfus times M, and QE is C times M times delta T, which I got the next step. Then I put in the equation also this delta T is Tm minus T, Then I got this whole equation, which I know all the values. So I put in the equation the values and calculated it. The answer I got was Q is 11,010 joules, which is approximately 11 kilojoules. Finally, I wrote down the answer. The heat energy absorbed was 11 kilojoules.